Hello, in this installment, I'm going to go through all of the steps needed to make a good looking graph in Google Sheets. So I'm going to move over there now. This will look like what you see in Schoology after you open up the assignment, in this case for Lab 1, but in the future this will work as well. So here we have the instructions. I've already taken the time ahead of time to copy all of my data from Lab 1. You will actually have two sets of data, of course. One table for nose cone water, another table for the engine water. Now I want to create an XY scatter plot for each of my data sets. So if I had the engine water here, I would do all of these steps for that as well separately after I'm done. So I select all of my data. It is important, I'll note here, that my X data, my independent variable, is on the left. My Y data, the dependent variable, is on the right. And I'm going to highlight all of it. Then go up and just find this Insert a Chart button. And this will do most of the work for me right now. What you may find, mine defaults to this kind of graph because I've used it so often. What you may find is that your chart type comes up as a line chart. It'd look a lot like this. We want to scroll down and find the scatter chart. Then it'll look like mine. It's already formatted the sides. It's got the labels on the side. It doesn't have a very good title. So I'm going to double click on that and title it something more like what we did in class for the written out graphs on paper. And that was like how changing nose cone water. At flight distance. Good descriptive title. About the only other thing now I have to do is put that curve in. So I'm going to select this, just select one of my data points. It should come up as customize here, series. If it doesn't, go back and double click that point and it should bring it here. Scrolling down, I want to add a trend line. That's what Google Sheets or Microsoft Excel calls a best fit. Okay, and it puts a line there. It's a type linear. Before I change anything on that, I want to do two things. I want to label this with the equation, and you'll notice that it comes up right under my title. And I want to show the R squared. So the equation is the mathematical formula that describes that best fit line or curve. R squared is a statistical measurement of how well does this fit my data. The closer this R squared value is to 1, the better the fit is. This is very far from 1 right now. So I want to try different types of shapes here to see which one's going to give me the best fit. This is negative. That's even worse, meaning, and it just means it's a terrible fit. Polynomial. Ooh, I can see that fits my data better just by looking at it. R squared still only 0.23, so not a terrific fit. Can go to logarithmic, oh, much worse. And power series, also worse. Moving average won't do what I want. I'm not even going to click it because you notice, well, I'll show you. If I do, I no longer have the formula up here. There's no way to do a formula. And furthermore, if I go back, now my formula and stuff isn't there. So I got to turn that on again. So don't try moving average, that won't be the case. In this particular case, I don't get a great fit from these data, but the best fit is provided by polynomial. And that's shown both just by looking at it and by the R squared value. Last thing to do here, so this graph is done. Last thing to do is list the optimal value for each independent variable, either on the graph or below each graph. So that optimal means the best. So that'd be right about here. Looks like that's very close to 300 milliliters of nose cone water. So I'm going to put down here optimal value, milliliters of nose cone. Okay, and that's done. I could go in now and submit this, although I'd have to do my second graph in a similar fashion with the engine water versus flight distance. Okay, Well, I hope that helps. A quick video. Don't forget you can go back and look at it again if you missed a step.